Hi guys, Nick here with BitGalaxis bringing you a new Unity 3D game development video, and today we're going to talk about wheel colliders and how we can power and turn wheels using the built-in Unity wheel collider system. So today we're going to cover the basics of a wheel collider, some of the properties that we can change and adjust. Then we're going to go over some notes about how wheel colliders work in Unity and how we can use them to move a vehicle. And throughout those notes, we're going to come up with some questions. And so we're going to address how to work around some of those default behaviors and make it work the way we want to. And then at the end, we're going to go over a simple demonstration of how I implemented wheel colliders for a project. And I'll also include the project files in a link below. Okay, so let's talk about the basic properties of a wheel collider in and of itself. There's some other setup that needs to happen, and we're going to go over that in just a minute. But let's just focus on the wheel collider and what we have within the wheel collider itself for now. So I have a wheel collider added to an object. This is not how you would apply it typically, but I have this black background, this box, so we can just see the details of that wheel collider a little bit better. I'm going to zoom in on it and just show you what this is. So you can see here on our wheel collider on the right, we've got a mass. So there is mass associated with this wheel. There's radius, which I have scaled down, scaled up. You want to make sure that your radius, if you have like a wheel mesh, that it's actually matching the size of your mesh pretty closely. There's a wheel dampening rate. I would not mess with this value. I would just leave it at this default value that it comes with. You can play with all of these as you want to learn and practice with it. But then by default, I've set the suspension to 0, the distance, but it actually starts out, I think, with like 0.25 or 0.5. And so what that really means is that your wheel's position is going to go up and down, and that suspension distance is at minimum when you have a weight or a force or a combination of the weight and the force being applied to it. It's going to squeeze the suspension, right? So at a minimum, the wheel is going to be right at this axle, so your car might compress the spring or the suspension down to 0, but it can be up to a maximum of like whatever distance you set here. So your point, you might see on the wheel that the wheel is actually like, well, I set the wheel right in the middle, but then for some reason the wheel collider's below it a little bit. Well, when you find that, it's because that's actually calculating the suspension distance. Where's the wheel right now, because there's no forces being applied. If you want to know if it actually is centered correctly on your wheel, you want to set that distance to 0 at first, and then you want to apply how much actual suspension distance you want to give it. So, so play around with these numbers here. Now, starting out, you will have your spring and your damper at some default values. I would leave these at the default and then play around with these. With wheel colliders, you can actually get some crazy physics issues if you make these values too high, because they're going to have these odd forces being applied to them. So these are things that you want to play around with. And then there's also a bunch of other values here, and I'm not going to go into too much details, but I would leave most of this at the default. If we go into all these things, maybe that's more of an advanced thing we can talk about at a later point, but these are like mostly all this stuff here, I leave it as is. But it does affect how your wheel interacts with the ground and how it moves forward, things like that. Now let's jump into some of our notes about setting up. Okay, so some prerequisite notes for setting up our wheel colliders. The first thing we need to know is that wheel colliders are not visible during gameplay. So just like any other collider, they're invisible. When you play them, they're not going to be shown unless you have an associated mesh with them. So in some sense, you could use wheel colliders to fake a hovercraft. However, you should remember that wheel colliders will collide like a wheel, so expect the behaviors to be a little bit different. We also need to talk about a minimum setup. So the minimum setup for wheel colliders is you have to have a parent object, and on that parent object you have to have a rigid body. And it's optional to have a collider, but typically you would want to have a collider on your vehicle anyway, because your vehicle has a physical body. You don't have to, but the rigid body is necessary, and you do want to have some mass on that rigid body. So then once you have your parent object that has a rigid body, some child object, it doesn't have to be like, it can be a direct child or it can be a child and a child. But you have to have a child object that has a wheel mesh if you want to be able to see the wheels. And then you also have to have a different child object with the wheel collider. You cannot have a wheel collider component on an object that has the mesh itself. And I'll explain that a little bit later, but it is required that they be separate. Okay, so for some additional notes, the best way to make the visible wheel mesh match the wheel collider is to set the mesh rotation and position equal to the collider position and rotation on each fixed update. So why not add the collider component to the mesh object? Well, if we do this where we match it with code, the wheel collider as a component on an object might change relative to that object. So because it's also dependent on that object's position, then if you update it via code, I'm a component, my parent position is now going to be relative to me, where I'm at now, my parent changes, but I'm going to be relative to physics, then I have to change relative to my parent. So where this really plays is in the spring value. So let's say that I have a certain force and my spring needs to compress a certain amount. Well, I'm a wheel and my spring is here and my parent then has to update to my position. Well, now the spring is shorter or the spring is longer. What you'll see is that you get these wonky physics because the parent moves to the position of the wheel, but the wheel moves to the position of physics. And so we're changing the physical properties and the laws that it has to adhere to. So the parent changes, the physics changes, and it makes these wonky physical outputs that really mess up and don't look good. It goes crazy. So that's why you have to have a stable point that the mesh is going to be based on the wheel collider, and the wheel collider is based on a stable parent. And so that mesh is only, both of those are based on a stable point for which they're calculated. So another note to make is that Unity automatically aligns wheel colliders to face forward. What does that mean? Well, let's jump into an example here and look at this setup. So here I have a buggy. This is a little buggy I've made and it has bugs. So I have these four wheels on here, and just like I've said in the setup, I have a parent wheel object that has both a mesh and a wheel. I did this for each of these. And so these wheels here are my right wheels, and then these wheels here are my left wheels. Now you can notice that my left wheel has a rotation of 180 on Y, and my right wheel has a rotation of 0. So they should work, right? If I play this, let's see what happens. And you'll see automatically these left wheels have rotated back 180 degrees because Unity automatically makes them face forward. Why does Unity do that? Well, Unity does that for convenience. So if you put a wheel collider in, you change its position 180 degrees, well, now it's going to go backwards. So the left wheels would go backwards if they did that. So it puts all these objects on an axis facing forward. So as we just explained, rotating a collider 180 degrees on the y-axis would make it move backwards when applying forward torque, but the collider will automatically correct in play anyway and will ignore rotation applied to the editor or scene. So some obvious questions we have then, as like, if you can't turn a wheel 180 degrees, how do you use one wheel model for left and right wheels? So the obvious answer is you can offset the rotation of the mesh by 180 degrees, or, in my opinion, scale the X value to -1. So let me go and demonstrate that. Here I have my boring buggy, and with my boring buggy, my left wheels, my rear left wheel here, has a scale of -1 on the X. And the same thing with this left wheel here is a scale of -1. And so now those wheel colliders, they're all facing forward, they're not rotated. We press play and the issue is fixed. And now we have a car that flips because I put too much power into it. But you can see there, really simple fix for that. The other option is just make a separate mesh for left wheels versus right. But wheels need to turn. How do we make them turn? Well, the wheel collider actually has a steer angle property, and you set that steer angle property with values, whether it's input or anything else. But what if I want to make my left wheel go backwards and my right wheel to go forward? Well, you can. You just have to set your steer angle equal to 180 degrees F. And if you want to be able to steer the backward wheel, then always set the steer angle to the turn angle value that you create plus 180 degrees F. So let's demonstrate that. Okay, so in my scene, I have set up my cray buggy, which is in the scene. All these wheels are actually just right wheels. You can see there's no left wheel. I haven't changed it. They all move right. And then I have actually set up an offset. So the offset is just going to be when it actually plays, that steer angle becomes whatever that offset is. So it's going to be 135 for this wheel, 45 for this wheel, 315 for this wheel, and the other wheel is going to be 225. And what that should do is it's going to set the turn angle to be all perpendicular angles. And then each of these wheels is going to be turning so that forward is counterclockwise and backwards is clockwise if you're looking from above. So you see each of these wheels rotates like this, and you can even go backwards, and that's really all you can do. You can't even, you can steer these a little bit. I forgot, because my steer angle on two of these wheels is 30 degrees from the offset. So there is a little bit of steer there, but you're kind of not in good shape. If you see them steering, there's not much they can do because it's already so wonky anyway. So anyway, that's an example of a crazy setup that we have. So again, if you want to make it do that, you just have to have a turn angle that you're calculating, and then you're adding 180 degrees F or whatever offset you want. You can make it anything, and it'll be crazy. So a simple setup. So here's how my demos have been set up so far. I have a vehicle object, and that vehicle object has a script for the vehicle. It has a rigid body component. It has a box collider component. It has a vehicle mesh component. It has a vehicle mesh as a child object, and then it has 4 wheels as child objects. So we also have 4 wheel objects. So the wheel is an object that consists of a wheel script as a component, a collider object, which is just a child object, and then on that collider object is the wheel collider component. So it's not, the component is attached to the child, and then there's a wheel mesh, which is a child object of the wheel. So let's go jump into how this simple setup is set up kind of in a diagram. So the wheel script contains public functions that the vehicle script can call. So how does this work? Well, our user, us, is actually interfacing with the vehicle. So on the vehicle, we actually put in our input where we have the vehicle. We say, what's our horizontal input? What's our vertical input, right? But we set in here this public array of wheels. So when we have this array of wheels that's public, in the editor, we can say how many wheels we want to have. And we can also then say, we can call those wheels. So we have this function, for each, W in wheels. So we would want to put this in fixed update. Here, we just want to put that as a public variable. But in this for each, we want to put that in fixed update. So for every one of these wheels, so we say wheel W, which is just a variable in wheels. So what we're basically saying is we pick, let's say we have 4 wheels. For every wheel W, for each wheel in this wheels list here, we are going to call the public function for steer, the public function for accelerate, and our update position. And that accelerate takes input for the forward value or the vertical input, the up and down arrow keys. The steer takes the horizontal input, so we put in our input. So for each wheel, we basically say, hey, do this. And so the vehicle is then calling this variable on the wheel script, and the wheel responds to that. So effectively, the user interacts with the vehicle. We put a wheel into this array of wheels. And then from that vehicle, we then tell the wheel, hey, wheel steer, wheel accelerate, wheel update position. So the update position is where we're taking that mesh and matching it to the wheel collider's current position. So let's go ahead and review what that looks like in code. So let's just open up a wheel, and we have a prefab, a wheel prefab. Ignore my terrible organization right now, but I have a prefab wheel here, and on that wheel I have a wheel script. I have some properties for that wheel script, and one of those properties is powered. Remember how our wheel script can take the input for accelerate? Well, if it's not powered, it ignores that input. And then if it wants to steer, the max angle is 30. So whatever input I give it, at most, it's going to go up to 30. The input it's going to get is somewhere between 0 and 1. So if it's 1, it's going to turn 30 degrees. Sorry, if it's negative 1 and positive 1. So if it's negative 1, it's going to go 30. And if it's negative, if it's negative 1, it's going to go negative 30. If it's positive 1, it's going to go positive 30. That's the max steer angle for it. And then the offset is, that original, when I made my crazy one, what that's going to change to. Okay, I'm going to look at the buggy here. And what we can see on this is the right left wheel. Let's just look at what I have for this script here. I have the checkbox that it's powered. So when we accelerate, this wheel will move. And the max angle is 0. So this wheel does not turn. And then my offset is 0. So that means it's never going to turn. It's just always going to be at 0 degrees, always moving forward. And so this is a rear wheel drive vehicle, and the front wheels turn. So if I go back to my other rear right wheel, again powered, max offset is 0. The front left wheel, oh, it's also powered. I have them all powered. Maybe I need to undo that. I'm going to undo four-wheel drive here. And we can see, if we do that, we might see some different properties. So we see a little bit of different properties when we have just rear wheel drive. And so I made it roll still, but it does feel a bit different. It's not quite as snappy. Now, the other problem that I didn't account for is when I power it, each wheel gets the maximum power. When in reality, an engine's power is going to be evenly divided by the number of wheels. And actually, it's way more complex than that. I really grossly simplified that. Anyway, those are the properties we have. And if you want to look at the wheel code, it's actually not too complex. Let's just go ahead and open it up and look at it in Visual Studio. So the wheel has this bool for powered, max angle. In this case, I put 90F by default, but I changed it in the editor. And then the float of the offset as well. Then there's a private float for our turn angle, the private wheel collider, which is what we're grabbing from the wheel, and then the private transform of the mesh, or the wheel mesh. So at the start, I'm grabbing that collider, and I'm also grabbing that mesh. And the reason why I'm doing it here is so that I can use that prefab. That prefab that I made is completely independent. I kind of forgot to mention this. I made the wheel a prefab, and so the wheel script automatically knows I've got to have a mesh collider and a wheel collider, and so I can always just add another prefab as a child to the buggy, and then I can go to my buggy and then add another wheel, and then the wheel automatically has all the properties it needs in order to work. I need to rename this one, but by doing it the way I did it, I can just keep adding a wheel by dragging it in there, and I don't have to configure anything else. It's just the wheel itself contains the properties it needs to work. And I shouldn't do this here. I could probably move this around, and you can see here on this wheel, one of the problems that I have is I made the wheel collider too big. I need to change the radius of this to be, I think it's 0.31. I forget what these other ones are. Yeah, they're 0.3. So I'm going to change this. But if I change this and I play it, it's actually going to act as a wheel at its current position, and it's going to do some probably very weird stuff. I'm kind of surprised. Yeah. So can't add a wheel there. But the wheel is self-contained. I'm going to remove this. Because of the script, we basically just have the mesh. It finds the mesh and the collider right away. We don't have to add those, through any other components. It's a self-contained wheel, and as long as the parent it's added to has the rigid body, the script, and the collider, you can just add it. Very straightforward. And so we grab those components. Then we have our public steer function, which gets called by the script. So we can turn. Our turn angle is always going to be the input from here that gets set from the other script. And then our max angle plus our offset. And then we have our collider steer angle. So remember, the wheel collider has this public function or this public property of steer angle, and we make that equal to our turn angle. Then we have our public void accelerate. So here we say if we are powered, remember that checkbox. If we're powered, we can apply motorTorque. So the wheel collider has a motorTorque function, or actually has a motorTorque property. And I'm going to set that to power input. So whatever our input is, so this is actually, the engine needs to specify how much power to give the wheel. So the wheel doesn't control that, the vehicle does. And then I also tried to say here, if it doesn't get powered, then there's no brakeTorque. And that is just to make sure that the wheel, it shouldn't, but the wheel isn't braking, because if it is, it's going to slow the vehicle down. And lastly, we have the public void update position, which is where we're taking the position and rotation of our current object. And then we're going to say the wheel colliders, we're grabbing its world position, and we're setting its position and rotation. We're basically just putting it into these two values here. The out is just a pointer that says put a value here. Without reassigning a value, we're putting a variable in there. So we're basically just saying, hey, put these positions here. And then we're then going to take our mesh. Remember that mesh we captured up here? We're taking that mesh's transform, position and rotation, and setting the position equal to the collider position, and their mesh rotation is going to get set to the collider's rotation. So that's what the update position function does. All of this is getting called from the fixed update on the vehicle script, which I have buggy script. I've commented out some old code from a previous video, but you can see here we have our power, our torque, our gravity. This was for the previous gravity demo, so you can ignore this. It's not being used. And then the torque also is not being used. That was just so I could rotate the buggy for another piece. But the power is still being used, which is what we're actually sending in our fixed update to the process forces. We are doing, you can see here that for each wheel, WN wheels, we're steering, accelerating, and updating our position. So our acceleration is our input times our power, whereas our steer is only our input because we have a max angle on the wheel, and that's being applied. So whatever the input is times that max angle that for the wheel. You could change this if you want to have a max turn angle per like the vehicle specifications, but then if the vehicle is defining that, then you might then what you would find is your back wheels would also have to turn that maximum rate. So you should set it per wheel, not per vehicle. So that's everything that I have for you guys today. I know I didn't cover all the code in this, but I covered everything that was relevant. If you want me to kind of go over details of that, just ask a question in the comments. If there's something that I didn't cover or I forgot or just doesn't make sense, I will provide all these project files in a link below. That'll link to a GitHub page where you can download this project and play around with these files. If you liked the video, hit that like button, and I hope to see you next time.